This video shows how to treat ink corrosion on paper objects. It also shows the 4 treatment baths, the materials needed, and the steps to follow. Objects damaged by ink corrosion must be treated to prevent further degradation of the paper. The calcium phytate calcium hydrogen carbonate treatment is suitable for this purpose. The treatment for ink corrosion is divided in 4 steps: the aqueous treatment, the complexation, the application of an alkaline reserve, the stabilization. For the water bath, demineralized water is used. The tub is filled until the object is sufficiently covered with water. For the complexing calcium phytate solution is prepared. For this, following supplies are needed: phytic acid solution 40% per weight, calcium carbonate powder, demineralized water, ammonium hydroxide solution, pH test strips, a beaker, a pipette, a spatula, a glass stirring rod, a magnet stirrer, and a scale. When preparing the solution, personal protective equipment such as gloves, glasses, and a coat must be worn. First, each substance is weighed out. For 5 liters of calcium phytate solution, 14.4 grams of phytic acid solution and 2.2 grams of calcium carbonate are required. On a magnetic stirrer, gradually add the calcium carbonate powder to the phytic acid solution. This will result in a pink-brown solution with a foamy consistency. Next, a small amount of demineralized water is added to the solution while still mixing thoroughly. The solution is then poured into a beaker with a capacity of at least 1 liter. To ensure that all the solution is transferred, the small beaker is rinsed once again with demineralized water, and the remainder is poured into the larger beaker. This is then filled up to 1 liter with demineralized water. The calcium phytate solution is poured into the tub for the complexing bath, and 3.5 liters of demineralized water are added. To adjust the pH of the solution, ammonium hydroxide solution is added with a pipette, and the calcium phytate solution is stirred with a glass rod. Using a pH test strip, the pH of the solution is measured. The same process is repeated until a pH of approximately 5.5 is reached. For the application of the alkaline reserve, calcium hydrogenate carbonate is used. The water is filled into the tub. For the stabilization, 0.2 to 0.5% gelatin is used. Low bloom alkaline digested type B gelatin is suitable for this purpose. Shortly before stabilization, the gelatin is heated in a water bath at a maximum of 60 degrees and added to the tub. Before treatment, the object needs to be humidified. Learn more about humidification in this video. The object is placed on fleece in a water bath and carefully immersed. Particularly fragile objects should be additionally supported with a sieve frame. By washing out the soluble degradation products, especially the free water-soluble iron 2 ions, calcium phytate and calcium carbonate can be better absorbed later. The aqueous treatment takes 10 minutes, during which time the tub is gently moved. The object is then removed from the tub and left to drain. Before the object is transferred to the next tub, it is couched between sheets of blotting paper. Next, the object is carefully immersed in the calcium phytate bath for complexation. By doing so, the catalytic activity of the iron ions is inhibited. The bath takes 20 minutes. The tub is gently agitated every so often. Finally, the object is removed from the tub and couched again with blotting paper. The bath for the application of an alkaline reserve takes 20 minutes. The tub is moved gently from time to time. Next, the object is couched again between blotting paper. Stabilization in the gelatin bath takes only 1 minute. This step is essential since ink corrosion can also affect the sizing. In addition, gelatin can bind metal ions to a certain extent in the future, preventing further damage from ink corrosion. Special care must be taken during drying because the degraded paper areas and the unaffected areas release moisture at different rates. First, the object is dried between fleece and blotting paper for 5 minutes. Next, the blotting paper is replaced and the object is left to dry for another 5 minutes. Then the blotting paper is replaced with felts and the drying stack is weighted down with boards and weights. After the calcium phytate calcium hydrogen carbonate treatment, an iron 2 test can be performed again to check whether the treatment was successful. The calcium phytate calcium hydrogen carbonate treatment is divided into 4 steps. Before treatment, slow humidification is important, followed by careful drying, since the degraded areas in the paper react differently to moisture. To determine whether the treatment was successful, an iron 2 test can be performed.